Hello guys, so welcome to session 11. In this session we'll discuss completely about OSHA and miscellaneous standards. Okay, this will be the last session in steel detailing training sessions. So let's start the session. OSHA. So let's have a brief introduction about origin of OSHA and the objectives of OSHA. OSHA stands for Occupational Safety and Health Administration. It's an agency found in US in 1971. Like around that time period there will be lot of accidents which are happening in manufacturing or fabrication companies as well as site works. So to avoid that injuries, they founded this administration called OSHA. Okay, the main objective of this OSHA is to ensure safety and healthy working conditions for all the working personnel and to set and enforce the workplace to follow some particular standards for the safety of workers. Okay, if required they will provide training also, and they will do some inspections if any organization is not following that OSHA norms, so they'll take some actions as well. So that is how OSHA works. So at every fabrication shop and at every site work at regular intervals they will do inspections also. So this is actually origin of OSHA, and there will be some regulations in OSHA which will affect structural steel and miscellaneous steel as well. Okay, those regulations we'll discuss in this video further. For our easy understanding, I just divided OSHA regulations as for columns, for beams and other OSHA regulations, and then miscellaneous standards which are also called OSHA regulations for stairs, handrails and ladders. Okay, first we'll see OSHA regulations for columns. Okay, for column minimum anchor bolts should be 4 anchor bolts, and if it is a small post then minimum anchor bolts should be 2. Okay, means at column base plate condition these we call anchor bolts. So these anchor bolts should be 4 for a column, and if it is a post it should be minimum of 2. Okay, and then lifting holes or lifting lugs. So what are lifting holes and what are lifting lugs? For example, if you just take a W column, this will be the top of W column, right? So they'll just punch a big hole of around 2-inch diameter. This they call it as lifting holes. In these lifting holes they'll insert an erection pin. Okay, so that erection pin will be clamped on both sides and they'll lift. In this way, to lift the column they'll use lifting holes. So when they'll use lifting lugs, there will be 2 conditions where they will use lifting lugs. Example, see, this is my column and there will be a moment connection or something, so that I need a cap plate to my column. Okay, at this condition if I need to provide lifting holes, I will just add one more plate with 2-inch dia hole in it. So this plate I call it as lifting lug. In the same way, if the column is HSS column, you can't provide 2-inch dia through hole into the HSS, right? It will be very cost for fabrication. So instead of providing 2-inch dia through hole in HSS, we'll provide a cap plate, and then to that we'll provide lifting lug, which will have a lifting hole. Okay, and then safety cable holes and column splice location, and then fall arrest cables, right? So if the building is more than one framing, which means if it is a multi-storied building, let's say this is the ground level, okay, columns, and this is level 1, this is level 2, and this will be roof. So at these intermediate levels we need to provide safety cable holes around the periphery of the building and around the openings for stairs and elevators. Okay, that safety cable holes will be of 13 by 16 dia, which will be punched to only periphery columns at a height of 1 feet 9 inch from finished floor. One hole they will punch, and 1 feet 9 inch from the first hole they will punch the second hole. Okay, so from the finished floor it will be 1 feet 9 and 1 feet 9. If the column is W column, they will punch the holes to keep the safety cable holes pass through the holes. Okay, if it is a HSS column, they will provide small plates with hole so that they can insert cables into these holes and they will keep passing the holes. Okay, these holes are called safety cable holes. Also this one, this is fall arrest hole. This will be at 7 feet height from the top of steel, means top of framing. Why we will keep this fall arrest hole is when erector, while erecting remaining beams or while installing deck or whatever, that conditions, there will be a cable running like that which is passing through that fall arrest holes, and that fall arrest hole will be 7 feet from the top of steel. Okay, so he will be having a belt and he will be having one rope with two buckles at both ends. One buckle he will be tied with that belt what he wear, and another end of the buckle he will hook with this fall arrest hole, so that whenever he becomes he slips from the beam, then it will prevent injury. And now this is column splicing. Usually this column splicing should be at 4 feet from the top of steel. It should not be more. Okay, why? Because after installing this column and while erecting this column and doing splice, if the splice location is very high, erector can't able to do splicing properly. So for easy bolting or welding while doing this splice connection at site, we will make this splice height is 4 feet only. Okay, so that's all about OSHA regulations for columns. Now OSHA regulations for beams. At both ends of the beams, so there should be 1 rows of bolts minimum before releasing the crane load, which means if this is one column and this is another column and in between there is a beam, let's say, and with a shear tab connection. So this, let's say this connection is having 4 rows and this also having 4 rows. So they'll lift the beam and they'll keep this beam in place using crane, and before releasing the crane they'll install the first bolt here and first bolt here, and then they will release the crane. Okay, and then they will install the remaining bolts. Okay, and whenever we are detailing a beam connection, we need to make sure if this is center line of the beam, the connection number of bolts that should cross the center line of beam. So that is second point. Minimum number of bolts should cross the half depth of the beam. Okay, and then shear tab directions at periphery and around the openings. Now let's see. if these are the columns and these are the periphery beams, and in between we have different beams, infill beams also there. Now these beams at periphery beams, this shear tab should be inside always. Okay, so that beams can come from this side and it will be bolted here and here. Beam can come from this side and it will be bolted here and here. Beam can come from this side, it will be bolted here and here. Okay, when it comes to opening location, this is a column. Let's say this is a stair opening. Okay, and you will be having a beam here, here, here and here, and these beam shear tabs should be this side, so that from inside the opening beam will be erected like this. Okay, and now there will be conditions where we need to weld something on beam top flange. Let's say we have a beam with studs on top of it, so that there will be one concrete wall which will be cast in sight. Okay, for this I need to provide these studs on to be welded on beam top flange. At this condition we should avoid these studs in shop, because while working, that erectors or who will do bolt installation and erection of the beam, guiding the crane operator and all, those will be working on these framing beams only. So we need to make sure and we need to avoid shop welding anything on the beam flange, because if anything will be shop welded and while working on that beam, they may get tripping, because if we weld anything on beam top flange in shop, so it may leads to tripping hazards at site. Now there are few more regulations which will be used particularly by some fabricators as their standards, but these usually we will not use unless guided by erector or fabricator. Okay, so one is rig hole. For example, like there is a beam with EOS bend plate of, let's say, 2 feet EOS. Okay, now if you want to lift the beam, so usually what we will do is we will wind up the complete beam with iron chain, and then we will lift it with the crane. But this joint, due to this more EOS value, this welded joint will be disturbed if you lift that much weighted assembly. So to avoid that thing, exactly at beam midspan we will provide a 6 inch by 6 inch square hole in the bend plate. Okay, then what will happen? Chain will be winded up using that hole and then they will lift. So this kind of holes we call it as rig holes. After erecting the beam, this hole will be covered with a filler plate and then it will be field welded. Okay, and then hand hole. What is hand hole? Let's say this is a column and this will be opening. So this is a beam, this is a bend plate, this is another bend plate, and these are beams. Now let's say there are shear tabs like this and you want to insert these bolts and tighten. To tighten, if this is 12 inch, let's say, means 1 feet, let's say. Okay, now to tighten, okay, you can tighten from this end, but to insert the bolt into the place, you have to insert from this end only, right? So at this condition, we will provide a 6 inch by 6 inch hand hole in the bend plate, so that into that hole erector will insert his hand and he will insert the bolt here. After complete installation of these bolts, again this hole will be covered with filler plate and it will be field welded. So that is the purpose of hand hole. Now catenary holes are safety protection holes. So earlier what we have discussed is, see, if this is a framing and there will be like this infill beams, like hundreds of infill beams are there. So what we have is, we have safety cables passing at the periphery, right? We have safety cables passing at the periphery using holes which we have provided in columns. We call it as safety cable holes. How about the beams? Okay, now if you want to walk on this beam, because there will be some RTU and you need to cut the deck opening for drainage purpose or something, and some erector want to work on this beam. So at that condition, he can't hook this beam flange directly to his belt, right? So at that condition, what we will do is, if like this beam is there, usually from the beam top flange at 8 inch, we will provide holes of 13 by 16 on beam top flange. We call these holes as catenary holes. Okay, and there will be a cable tying up these two holes, and erector or some person who is walking on this, he will tie his buckle to this cable while working on this beam. Okay, those holes we call it as catenary holes or safety protection holes. Next, there will be some unavoidable conditions where for sure we need to weld the things on beam top flange. So at that condition, if you need to weld something, then we need to paint them with yellow paint, so that while walking, erector can identify it very quickly. Okay. So that's all about beams, and there will be few other OSHA regulations which we use in structural steel. I can say main steel. Okay. So wherever you are going to do field welding or common bolt sharing conditions, we need to use erection aids. Okay, let's say this is a HS column, this is a HS beam, and you want to do field welding. So before doing field welding, what you will do is, there will be two tabs. One tab will be with the column and another tab will be with the beam shop welded, and the two tabs will be having holes and there is an erection bolt inserted into the hole. The same condition will be repeated on the other end of the beam as well. So after providing these erection bolts, he will weld the beam all around, and then he will remove this erection bolt and he will remove these tabs also. So these are the erection aids for field welding conditions usually. So it may not be like these tabs only, it may be something else also. Depending on the condition and depending on erector preferences, we will use the erection aids. Okay, and I mentioned here one more thing as shearing bolt conditions. Shearing bolt conditions means there will be one condition where if this is the column web and one beam is coming like this, W beam with a clip angle field bolted. On the other side also it should be bolted like this. Okay, so first column will be erected and then first column will be erected and then this beam will erect. While erecting this beam, if you install these bolts completely, again he need to remove these bolts, and after erecting this beam also he need to reinstall it again, right? So these bolts we call it as shearing bolts. At this condition, what we will do is, to this beam we will provide a erection angle so that this beam will come and it will rest on the angle. After coming this beam, we will install the bolts together and then we will remove this angle. So that is bolt shearing condition. And then erection bolts for vertical bracing. If there is any kind of vertical bracing connection, like if this is the beam and this will be the gusset, this will be HSS with cutting in between the HSS, and I want to just insert and field weld at this region. So before doing field welding, there will be hole in the gusset and through hole in HSS. I'll insert an erection bolt and then I'll do welding. That erection bolt will be at least one erection bolt at each end we need to insert for vertical bracings before doing field welding. Okay. Now there will be different crane capacities that erectors use at site. It varies from project to project, means it varies depending on size of the project. Okay. Now let's say erector crane capacity is of 6 tons. So then what will be his preferable handling weight is usually 4 tons. But if you have a beam of exactly 6 tons, then you need to, on the beam in fabrication shop itself, on the beam web or on the beam top flange, sometimes at both the conditions also, you need to paint this note so that erector can see that beam and he'll get to know it is already 6 tons and he'll take necessary precautions while lifting this beam. Okay. So these kind of notes also we only should provide as a detailer. And now after installing complete deck, for example for plumbing purpose or to install RTU frames or something, if you just cut some portion of deck to form an opening, and if that opening size is crossing 1 feet 6 inch, we need to make sure that there is something structural framing which will support those deck edges. Okay. So vent holes and weep holes. Vent holes and weep holes will be provided for galvanizing process. After fabricating complete assembly, so some beams will be having no painted, some beams will be having red oxide or standard shop primer, but some beams need to do galvanizing. That can be hot dip galvanization also. So in that process there will be a very big tub in which molten zinc metal will be heated up and it will be converted into liquid form. In that big tub these beams will be inserted, which means just dipped from top, and then they lift it back. So at that purpose we use vent holes and weep holes. Okay. Now I'll just show you one example. Let's say we have a HSS this is base plate, HSS column, let's say this is base plate, and there will be a closer plate attending. Okay. Now I'll say inside this HSS is completely hollow and it is filled with air, correct, right? And there is no space so that air can come out of the HSS. Now if you dip the HSS like this only into the galvanization tub, this inside air will be forming more pressure on walls of the hexes, and it can cause some kind of blasts also. Okay, means exploding the assembly. To avoid that conditions, we will provide holes in these plates. Okay, holes in these plates. These holes we call it as vent holes or weep holes. Okay, now we understood why we need to provide holes. Now let's see how much will be the hole size. Let's say this is the hexes and it is covered completely with a plate. Okay, now you need to provide hole here and here. Now this inside area, cross-sectional area is 100%, means this vent holes, what you will provide, vent holes or weep holes, combined these two cross-sectional areas should be 30 to 35%. Okay, and usually this hole sizes will be 13 by 16 square. If hexes is bigger and if you provide two holes and it is not coming into 30 to 35% of the cross section area, 30 to 35% of the cross section area, then you need to provide two more holes in these corners also. Okay, so that is how we will provide vent holes or weep holes. So we already discussed OSHA is to make safety environment for working personnel in fabrication shop also and at erection site also, right? So this vent holes and weep holes concept is to provide safety work environment at fabrication shop. Now we'll go to some miscellaneous and their standards also. Okay, let's see stairs. Stairs are usually of 7 types. Okay, one is L-shaped stairs. If this is one elevation and this is one elevation and you need to climb from this elevation to this elevation, what you will do is, let's say it is 20 feet. Okay, this is 0 feet. From here to here you will make one intermediate landing at top elevation 10 feet and you will make steps and you will climb like this. Okay, and then you will make steps and you will climb like this. This type of stair we call it as L-shaped. Okay, now in the same way, if this is 0 and this, let's say 40 feet, directly you can't make 40 feet, right? It will be very steep. Since if you see the cross section, if this is the 40 feet and this is 0 feet, means you need to provide something like this with continuous steps and all, right? So instead of that, what we will do is, what we will do is 0 to 10 feet we will make few steps and this will be intermediate landing, and then 10 to 20 feet, this is 20 feet, we will make few steps, and then this will be 30 feet, we will make few steps, and then this will be 40 feet, we will make steps. Okay, in this way, this we call it as double L. Okay, and then U-shaped. U-shaped means you guys already knows that, like this, let's say 5 floors are there and you need to go like this, like this, which means like this you need to make steps, right? So this, if you can see from top view, it looks like U-shaped, like this steps will be, and this will be landing, and again like this steps will be. Okay, here it is going top, and from here it will go top. So this is U-shaped stairs. And now monumental stairs. Monumental stairs means in many movies you will see like if you just enter into hall of a big house, and there will be, if it is a duplex house, let's say, there will be here railings, and you will have steps this side also, and you will have steps this side also, right, to get into that. These stairs we call it as monumental stairs. Okay, and then spiral stairs. There will be one pole, and to that pole stair will be, that we call it as spiral stair. Okay, these are monumental stairs. Okay, and these are monumental stairs. And now spiral stairs. These we call it as spiral stairs. These things we call it as spiral stairs. Okay, now in a stair, what are the terms actually? This we call it as landings. Okay, and then these landings will be connected using flight. We call this as flight. Okay, now we call these as razors dimensions. Okay, we call this as tread dimension. Okay, and now usually how it will be is, this complete stair will be supported with stringers. Like this, stringers are the channels which we will provide. If you just take this cross section, there will be one channel like this, and this will be tread, and it will be another channel like this, and here we will get handrails. Okay, on the channels. So now the line which is connecting all these tips, we call this as nosing line. Okay, now OSHA standards in this stair is that at ends of the stair there will be rails also, because by building those rails only you will climb the stair, right? This we call it as grab rail. The height of this grab rail is 2 feet 10 inch. Okay, and at this portion also, from this nosing point to here will be 2 feet 10 inch. Some people will do parallel dimension, that is incorrect. So if you just draw one vertical line, and where it touches the nosing point, and the same vertical line where it touches the top of grab rail, that will be 2 feet 10 inch. Okay, and then this rail we call it as guard rail. This will be 3 feet 6 inch. Okay, and even here also from top of landing it will be 3 feet 6 inch. and then to support this handrail there will be rail posts. Okay, this maximum center to center distance of these rail posts is 4 feet. Okay, and now for rails there will be small vertical rods like this, correct, right? So this inside to inside clear dimension in between these rods will be 4-inch maximum. These rods we call it as pickets. Okay, and now instead of like these rods, sometimes there will be mid-rail also like this. Okay, the height of this mid-rail is 1 feet 9 inch. This rail we call it as mid-rail. And then this tread dimension which I said you, this will be usually 11 inch. And this razor dimension which I said you, this will be usually 7 inch. Okay, if this is the top of stringer channel, this parallel dimension is there, right? This we call it as nosing dimension. This 3/4 to 2 inch. Okay, and now let's say this is the this will be the guardrail. Okay, and then this will be handrail. This will be the last nosing point, right? Then handrail will be extending little bit. Handrail will be extending little bit like this, and it will be again welded to the guardrail only. From the extreme end of the handrail and to this nosing point will be usually 1 feet. Now let's say one person is using this stair, okay, and he is climbing like that. I already said you this is the nosing line which is touching these points, right? So from that nosing line, if you just draw one vertical line from here to some distance, so that when he is climbing this stair, he should not hit with any other object, which means there should be some clearance, right? We call this clearance as headroom clearance. This will be usually minimum 6 feet 8 inch. Okay, and now if we take this section view of the stair, it looks like there will be, since it is a concrete stair, I'm saying there will be 2 walls and there will be steps like this. Okay, this width is there, right? This width will be usually 3 feet 8 inch for commercial buildings, and for industrial it will be 3 feet. Okay, and now for example you want to climb till 30 feet and 0 feet, and designer just ask you to provide a stair. You can't provide with how many steps you want. Continuously he can't climb the stairs. There should be some halting point after some portions, right? So for every 10 steps, 1 2 3 4 5 6 7 8 9 10, there should be one landing. If you didn't reach the actual height to which you want to reach, you need to provide a intermediate landing at least. After that again steps will start. Okay, so for every 10 steps there should be intermediate landing. So that's all about stairs, and let's see ladders. Ladders are of 4 types: pit ladders, ship ladders, cage ladders, roof access ladders. Okay, these are pit ladders. This on which he is just keeping his foot and going, we call these as rungs. Okay, usually this ladder width will be, means if you just take this ladder, it will looks like this with rungs. Okay, this into in width will be 1 feet 6 inch. Okay, and whenever you are just climbing the ladder will be getting support with some concrete wall or something. Pit ladder means. So the distance from the center of the rungs to the face of concrete wall should be minimum 7 inch. Okay, why? Because he is putting his legs like this, and mid of his leg will be resting on the rung usually. So this half of the feet should be placed in between this gap. If the gap is less than 7 inch, let's say only 2 inch, then he can't keep the feet properly on this rung while climbing. Okay, that's why the gap between the supporting wall surface to the center of rung should be 7 inch. And then this rung spacing will be 1 feet maximum. This is 1 feet. So this is all about pit ladders. Now let's see ship ladders. These are ship ladders. These looks like stair only. Okay, same here also. Riser will be 12 inch maximum, and this will be the landing, and these will be the rails. Okay, then cage ladder. When we do is, if this is the ground level and you want to reach some level at example 30 feet or more than 30 feet, that time you can't just provide a ship ladder or something like a pit ladder. You need to provide a cage ladder because height is more. If a user, when he is climbing like this till some height, he can be okay. After getting into around this area, due to more height, he feels uncomfortable, right? So that's why you need to provide cage ladder. So these are called cage. Okay, so when the height is 30 feet or more, then we will use cage ladders, and then cage will start at 7 feet to 8 feet from the finished floor. Finished floor means where the user will stand. Okay, and this will be 7 inch only, means from the face of connecting surface to the center of the rungs. Rung spacing will be 12 inch only maximum, and then these ladders should be connecting to this supporting wall, right? The spacing of that is 6 feet maximum. Okay, and this will be 4 feet. This is cage, right? And we call these portions as flat bars, and this we call it as hoods. Okay, hood to hood spacing is 4 feet. So that is how cage ladder looks like. And now this is roof access ladder. So if the height is less, only like 20 feet or something, then you will provide a roof access ladder. So at this roof access ladder, you will just remaining things are same. This rung spacing is 12 inch maximum, and this is 7 inch minimum. And then after climbing, just to climb onto that, you will be having railings also. Okay, that railing height is 3 feet 6. Okay, so that's all about ladders also.